we will discuss the problem number 15 related to the chapter 28. Calculate the power delivered to each resistor in the circuit shown in figure 28.15. This is figure, and this now we have to find the power delivered to these all resistance. There are two in series, and these two resistance are in parallel. So I must say that this current I will be divided into IA and IB. Okay. So now our current I will be equal to IA and plus IB. So total what because these are the parallel resistance, and though these are the in series. So as I have already explained many times in different problem, the total resistance will be equal to 2 plus uh, parallel will be right in the form of in parallel will be written in the form of 1 by 3 plus 1 divided by 1 and minus 1. So but series resistance will be add plus 4, and this will be give you the total resistance. When we add all these, then that will become 6 point by calculating it will be a sorry, when we had using the calculator, that will become a 6.75. 6.67. So this will be the resistance. Okay, now I have to calculate the current I, which is I have to calculate this current I. This will be equal to I. This I will be equal to as uh, that will be a delta V, the potential drop on this point, delta V over total resistance. So this will be a total resistance. So delta V is given 18, and total resistance is 6 point, as we have calculated, that is 6.67 ohm. Okay, so that will be by calculating, this will be equal to 2.67. Okay, so this will be our we have to calculate the power delivered on each. Okay, so this will be our I. Now I have to calculate the power delivered to the resistance. So the power, so power delivered to P, sorry, power delivered to passing through the this resistance 2, that will be, as I have already explained, that will be I square, that the same current is I square R2, and I is 2. I is 2.67 square. R2 is 2, so that will be equal to 14.2. 14.2. Okay, when we take the square of the 2.67 and multiply with the 2, then that will be a 14.2 watt. And this will be power delivered uh, to resistance 2. So same the power delivered to resistance 4, that will be I square, same I square R4 is 2.67 square 4, and so by calculating this, that will be 28.4 watts. Okay, now we have to calculate the voltage to find the other parameter. Voltage, we have to find the voltage drop on this point because the both have the same mean uh, voltage drop here. Okay, firstly, we have to find the voltage drop across this resistance, because when the current will be passed through this resistance 2 and 4, the voltage will be drop at from the 2 and the resistance 4 resistance. And so this change will be uh, after uh, um, decreasing the voltage from this and this, the result will be appear. Though, and then after subtracting the voltage drop here and here will be subtracted from the battery voltage, will give the voltage across this resistance 3 and 1. So firstly, we have to calculate the voltage drop at V2. So that will be a voltage drop V2, that delta V2, that will be, yes, that will be IR2. I is 2.67, R2 is 2 ohm. Okay, that dropping from here, and that will be equal to, after calculating, this will be 5.33 volt, and delta, sorry, and delta V4 will be IR4, and that will be 2.67 multiply by 4, and result will be 10.67 volt. But we delta V, which is drop, sorry, okay, I don't know what is the problem. Okay, delta V, which will be drop across uh, delta V, that will be we may say that the passing through parallel mean the delta Vp. Okay, so for these two circuit, delta Vp will be, which is the voltage that is the same for uh, delta v v a, and that will be same for delta v b, and that will be because the voltage and that will be the final voltage. This is 18 voltage delivered by 18 minus voltage drop across delta delta v2 minus delta v4. So that will be 18 minus 5.33 minus 10.67. So by calculating this, yes, we will get by subtracting these delta Vp, that is delta V A and delta V E, that will be give us 2 volt. So this is our voltage dropped across the delta VA, and cross this current IA and A and B mean 3 ohm resistance, mean from this 3 ohm resistance 1 ohm resistance. So uh, power delivered power delivered to 3 ohm resistance will be uh, delta VP. Okay, and that is because firstly I have to explain this delta VP is voltage drop across the A is 3 ohm. Okay, as from A is 3 ohm and B is 1 ohm, equal to delta V1 ohm, that is the voltage. So from here we will get delta, so we will get P P3, that will be a delta V3 over or you may say that delta 3 or delta P over 3 over that must be equal to 3 delta V3 square, and you may say that delta Vp square over uh, R3, sorry, R3 is 3 ohm, and so what will be the value? Delta Vp is 2 divided by 3, and that is equal to 2 square. Okay, that will be equal to 1.3 watts. Similarly, uh, voltage drop across the 1, that will be a delta Vp square over 1, and that is 4, mean 2 square over 1, that will be a 4 watt. So we will get all these result. This this is power delivered at 2. This is power delivered from the 4. This is power delivered to this resistance, parallel resistance 3. That's why I have used the voltage P, and this is power delivered to 1. So that will be the result. So mm, now we will discuss the next problem. Okay.